Welcome to Graphs of Polynomials for paper 1. So this topic, graphs of polynomials, is going to be delivered as it comes in the exams. So we're going to start the type of questions or the analysis or the kind of skills and knowledge that you need for paper 1. Then in the next video, we're going to look at paper 2. So let's get started. So here's the concept map. We're going to take a look at introduction. Then after that, we'll take a look at quadratic graph sketching. Then we'll look at quadratic graphs plotting. And we'll look at other graphs. In this video, we're going to look at quadratic graph sketching. Then we'll have a series of videos which are going to be dedicated to quadratic graphs plotting and other graphs. There's a difference between sketching and plotting. To sketch is just to draw something that gives you an idea of how something should be. We don't use graphs when sketching, okay? We just show the important points and then draw our graph. There's no need to use graph papers for sketching. So what is a polynomial? A polynomial is any algebraic expression having x's with different powers. So if you have an algebraic expression that has x's with different powers, it's a polynomial. So we can have a situation like this. If you look here, we have x's being separated by pluses, or it can be minuses, but here it's pluses, and they all have different powers. The first one is power 3. The second is power 2, the third is power 1, the fourth is power 0. So such things are called polynomials. So this is another example here. Actually, it's not another example. This can also be written like this. So power 3, power 2. Here power 1, sometimes normally it's not shown power 1 because we assume anything has a power of 1. So x power 1 they won't show. And x power 0 is not shown because x to the power 0 it's 1, and if we have 1 here times d, it's going to be d. So when there's just a number, you just know that there is power 0 at the end, but that's not even important. What is important is to know that such an expression is a polynomial. Then the interesting case that we have dealt with is this, which is called a quadratic. A quadratic is an example of a polynomial. A quadratic has 2 as the highest power of x. So x power 2, this is a quadratic. Then x power 1, then it's x power 0, which you can just write. So now let's go to the meat of this subject, of this topic. So for you to sketch a quadratic graph, which is the main concern of this part, you need 4 skills or 4 things to know. The first is the shape of the graph. The second is the y-intercept. When you know the shape, you have to know where it is going to cut the y-axis. The third is the x-intercept. You have to know where your graph is going to cut the x-axis. And finally, the turning point. The turning point is where the graph is going to turn. So let's take a look at each. We're going to start with some properties that we can get from an equation. So if you have been given an equation like this, y is equal to ax squared plus bx plus c, where a, b, and c are numbers. So this can be 2, this can be another number, this can be another number. Yes, so if we have this kind of an equation where of x squared with a number in front and x with another number and with another number in front and c just to be a number, then this is what you can get from here. If a is less than 0, if this number is less than 0, is smaller than 0, then basically it means it's a negative, because for a number to be smaller than 0, it has to be negative. 0.2 is greater than 0, 0.5 is greater than 0, but anything that is negative, it is less than 0. So if a is negative, then the shape of the graph is going to be like n. It's going to be shaped like n. Okay, so the way to remember is negative starts with n. So if this number here is negative, then know that your graph is going to be shaped like this, like n. So if, for example, we have this y is equal to negative 2x squared plus x plus 1, here it's negative, so it's going to be shaped like n, like this. So this is what I mean, like n. So if it's negative, it's going to be shaped like this. Then when it's positive, that is if a is greater than 0, it's going to be shaped like cap, to have a U shape cap. So for example, if you have y is equal to 2x squared plus x plus 1, 2 is positive, so it's going to be shaped like a cap, like this. So this is the first information that you need, the shape of the graph. You have to have an idea whether it's shaped like this or it's shaped like this. Next, you need to know where exactly it cuts the y-axis. Then also you need to know where it cuts the x-axis and where it is turning. So let's take a look at the second property, which is where it cuts the y-axis. So given such a graph and given this equation of the graph, then the y-intercept is always a single point. It usually cuts the y-axis at one point, and this c, just like in coordinate geometry, the equation of a straight line is y is equal to mx plus c. The c is the y-intercept, meaning that it is where the graph cuts the y-axis. So the point is always 0, c, because at any point on the y-axis, x is 0. So at any point here, x is 0. So if it cuts here, then it's going to be 0, whatever number is here. This number is always c. So if c is 5, then here it's going to be 0, 5. If c is 100, then it's going to be 0, 100. If c is negative 10, then it's going to be 0, negative 10 as the y-intercept. As simple as that. So if I've been given this equation, y is equal to 2x squared plus x plus 1, the y-intercept is positive 1, meaning that this, the graph for this cuts the y-axis at plus 1. And the coordinates of that point is 0, 1. Then for the x-intercept, which is the next thing, once you know the y-intercept, the next thing you need to know is the x-intercept. Where does it cut the x-axis? So x-intercepts for quadratic are usually 2. There are 2 for quadratic. Actually, always there are 2. So with that in mind, how do you get the x-axis, the x-intercept? So the x-intercept is actually the solution to this. So what you do is you get this equation, you equate it to 0, make y being 0. So when you do that, you start solving for x using whatever method you know. It can be using factorization or using the formula. So, but since in paper 1 you can't use the formula, so you have to factorize. You have to factorize this. Remember the process of factorizing. You look for product and sum. You do those magic, then you're going to be able to solve this. So, in short, x-intercepts are usually 2 and they are solution to your quadratic equation. For example, if you solve, let's say we solve this and we get x negative 3 and x2, it means our graph cuts the x-axis at negative 3 and 2. And the coordinates are, of course, negative 3, 0 and 2, 0. Why? Because on the x-axis, the value of y is always 0. Just like the opposite on the y-axis. So negative 3, 0 and 2, 0 are the 2 points where the graph is passing the x-axis. So we're talking about this being 2, 0 and this being negative 3, 0. Finally, you need to know the turning point or stationary point as they are called. So, what's with the turning point and the stationary point? I'm going to mention something about the stationary point. It's going to be very important when we're doing calculus. So, this point is called the turning point because that's where the graph turns. It is also called the stationary point because at this point, the graph seems to not to be curving as if it has stopped. Anyway, we're going to start that in calculus. So let's say this is our y-intercept here. This is the first x-intercept and this is the second x-intercept, and we know that the graph is this. How can we be sure that, the shape of the graph is this? In short, it is like an N. It looks down, okay? So with that in mind, how can we be sure that the graph is like this? Because we can have another graph like this. So if you see the second graph, it cuts at negative 3, 0. The y-intercept is the same. The x-intercept is the same, but it is turning here, not here. So you need to know where it is turning. That is the last information that you need. So how do you tell the turning point or the stationary point? So use your equation. the formula for the turning points, or the coordinates of the turning points, are the x value is negative b over 2a, so negative b over 2a, and the y value is given by negative b squared minus 4ac over 4a. So these are the coordinates. So you just get your b, your c, and your a, you plug in, then you have fun here. So the coordinates of the turning point is, of course, the x value and the y value, which you can just write like this. If you want, you can master this. By the way, this one, x is equal to negative b over 2a, is called the equation of the line of symmetry. So if this shape is cut in between here, so a line that's going to represent like the middle part of this is given by x equal to negative b over 2a. So you can be in a situation where they ask you to find the equation of the line of symmetry. The answer is just the x coordinate. But if they say find the turning point, it is the x coordinate and the y coordinate. So how to remember this? For me, I was using the quadratic equation, which I had mastered by then. For those who have mastered this, of course, it is given in paper 2, but for those who have mastered this, I could remember like the x value is just this part over 2a. Then the y value is this part without a square root, and also with a negative, this negative, as you can see, b squared minus 4ac is this one, b squared minus 4ac, with a negative over, but down here it's not 2a, it's 4a. That's how I used to remember this these formulas here. So this part was this and this part was this, but it's not important. It's just an insight. That's how I used to do it. What is important is find a way to master this, because in paper 1 you won't be given these. Let's take a look at an example. Sketch the graph of y is equal to x squared plus 3x plus 2. So we are going to draw our axis here, the x-axis and the y-axis. The first thing is to have an idea of the shape. So we can see that a here is 1. Okay, there's an invisible 1 here. So mean that the graph opens upwards. It's U-shaped. It has a shape of a cup because a is positive. That's one knowledge. So we know that our graph is going to be like this. We can't be sure where it's going to cut where, so we need more information. But we know that it's going to be like this. So the next is the y-intercept, which is this number here, which is just 2. Therefore, our graph is going to pass somewhere here where 2 is. So we can just approximate that 2 is going to be somewhere here, mean that the coordinates is 0, 2. So we can have an idea that our graph is going to be like this. But it can also be it can also be like this. It can be in different ways here. So it can be like this also, meaning that first it has a shape of a cup and it is cutting through 2. So with this information we cannot be sure. The third is to find the x-intercept. So get our equation, start solving. So we're going to look for product and sum, and we're going to I won't show how to do that. We then have to do that. When you do that, you're going to end up with this. Then we can factorize. We have this. Then we can factorize further. We have this, mean that x plus 1 is equal to 0 and x plus 2 is equal to 0. So x plus 1 is equal to 0. You can take 1, the other side becomes negative 1, and x plus 2 is equal to 0. When you take 2, the other side becomes negative 2. So our points are x is equal to negative 1 and x is equal to negative 2. That's where our graph is going to cut. So we have negative 1, negative 2. So we have an idea that our graph is going to be like this. In the first information, we knew that it has the shape of a cup. Second, we knew that it's going to cut here. Third, we knew that it's going to cut the axis here and here. What is remaining is the turning point. So where should it turn? Should it turn here, 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 or here? We don't know exactly. So we need to know the turning point. So for the turning point, let's just collect our A, 1, B, 3, and C, 2. Let's plug in our formulas. So this is the coordinates of the turning point. So if we put the values, where there's B, we put 3, where there's A, we put 1, and where there's C, we put 2. We're going to have this. If we try to simplify this or work this further, we're going to have this, and 9 minus 8 is going to give us 1, and we're going to end up with negative 3 over 2 and here negative 1 over 4. So negative 3 over 2 is just the same as negative 1.5, and negative 1 over 4 is just the same as negative 0.25. I like putting them in points for me to approximate. This is sketching. You can't be sure, so you just have to ask yourself, where can negative 1.5 be and where can negative 0.25 be? So if you're not sure about the math here, you can just solve on your own. I can't, I don't want to waste time explaining what was happening, like 4 times 1, 4 times 2, no. So I'll just continue. X here is negative 1.5, y here is negative 0.25. So where do we have negative 1.5, negative 0.25? So that's where we can have negative 1.5. It's just an approximation. It shouldn't be accurate. We're just sketching. What about negative 0.25? It should be somewhere here. Actually, I made a mistake. I wrote negative 0.5. It's supposed to be negative 0.25, meaning that it's supposed to be somewhere here. Okay, let's assume this is negative 0.25. Yes. So with that, we can just we want to see where these two lines are meeting. So we'll draw a line from negative 1.5 and a line from negative 0.5. Where they meet, that's our turning point. So we're talking about this line and this line. They are meeting here. So this point is negative 1.5 and negative 0.5. So from here, that's where the graph is going to turn. So our graph is U-shaped. It's passing the y-axis here. It's cutting the x here, and it's turning here. So we're going to start drawing like this so that it cuts the x at negative 2. Then it reaches here where it's going to turn. Then it will start rising up, passing through negative 1 and moving till it passes again through 2. Then it goes wherever. This is what matters. So doing that, we're going to have this as our graph. So this is how to sketch these kinds of graphs. This marks the end of this topic. And one thing I would want to emphasize is it's not always that they'll ask you to graph. Sometimes they'll graph for you, then they will tell you what's the coordinate of this. They'll give you the equation, then they'll ask you the coordinates of this, and what you have to do, you have to use this formula to find the coordinates. Sometimes they will draw this for you, then they'll ask you to find the equation of the line of symmetry for this. So you use this to find the x coordinate of the turning point, meaning that you're going to use just this part, negative b over 2a. So what you're going to have is x is equal to whatever you're going to plug in. In this case, it can be x equal to negative 1.5 as the equation of the line of symmetry. So they are very creative. They just want to make sure that you haven't mastered this, but you understand it. Anyway, this marks the end of the topic. Happy solving.